Hi, and welcome to Dr. V's Chemistry Webcast. Today we're going to talk about predicting products when we're given just the reactants of a chemical equation using patterns to figure out the products and write correct equations. Now this is actually a fairly high-level task. There are a lot of skills that go into doing this. So what we're going to do is use patterns to predict products, and the patterns we're referring to are the classes of reactions that we've already discussed. And if you haven't, you should definitely go watch my webcast on that. And then we'll review formula writing, which is usually what students find the most difficult about this. It's easy to make mistakes with your formula writing. And then use the correct reactants and products to balance equations. And that's really what we want to do here. The best way to do this is to do a lot of practice problems, and that's the approach we're going to take here. Try and do it on your own, and then listen to my solution. So here's the process we'll do for each problem. We'll classify the reaction by type, use the pattern from that classification to predict the products, write their formulas, and then we'll balance the equation. So let's get started. I have lead-2 nitrate reacting with sodium phosphate. So I've got an ionic compound reacting with an ionic compound. Oh, that means it's double displacement. 2 ionic compounds making 2 ionic compounds. That's the pattern. So what happens in a double displacement reaction, we can think of it as the cations switching partners. So the lead ion, instead of being with nitrate, would now be with phosphate. And the sodium ion, instead of being with phosphate, would now be with nitrate. Let's focus on the compound that will form between the lead ion and phosphate. We know lead ion here has a charge of +2. How do we know that? Well, it's combined with 2 nitrates, which have a charge of -1. So the lead ion must have a charge of +2. And phosphate, we know, has a charge of -3. So when these two come together, they can't come together in just a 1-to-1 ratio. That won't give us a neutral compound. So I need to select subscripts to make it a neutral compound. But if I have 3 lead ions and 2 phosphate ions, that would give me a neutral compound. So it's Pb3, parentheses, PO4, 2 for my first compound. Now we need to look at the formula that will form between the sodium ion and the nitrate ion. We know nitrate has a charge of -1. We know sodium ions have a charge of +1. So these two ions are going to come together in a 1-to-1 ratio. Don't be fooled by the fact that the sodium ion in sodium phosphate has a subscript of 3. We need to look at how it will combine with the nitrate ion. The formula of the compound here would be NaNO3. I need 1 sodium ion for each nitrate ion. And now that I have correct formulas, I can worry about balancing. You always make sure your formulas are correct before you worry about conservation of mass. Looking at the compounds, looking at the products, I see that there are 3 lead ions on the right, which means I need 3 lead ions on the left, so I can put a coefficient of 3 in front of the lead-2 nitrate. Looking again at the compounds on the product side, I see that I have 2 copies of phosphate on the right, so if I put a coefficient of 2 in front of the sodium phosphate, that will balance my phosphates. These coefficients give me 6 nitrates on the left and 6 sodium ions on the left, and so I need a coefficient of 6 in front of the sodium nitrate. Okay, I think that's good. That'll work. Let's do another example. I've got calcium metal reacting with aluminum chloride. I've got an element and a compound. That's my clue that this is a single replacement reaction. An element with a compound will make an element and a compound. Calcium, being a metal, is going to kick the metal out of the ionic compound. So calcium is going to replace aluminum. And therefore, aluminum will be the element that I produce on the product side. And then I have to think about the formula of the compound that will form between calcium and chlorine. Well, I know calcium, when it forms ions, has a charge of +2, and chloride ions have a charge of -1. So to make this a neutral compound, I'm going to need 2 chloride ions for each calcium. So it will be CaCl2. Do not be fooled by the fact that in aluminum chloride, the chloride had a subscript of 3. That's because aluminum has a charge of +3 when it forms an ion. But here it's combining with calcium, which has a charge of +2, so it's CaCl2. Now that I have correct formulas, I can think about balancing. I've got 3 chlorines on the left and 2 on the right, but I can easily take care of that with coefficients. So if I have 3 calcium chlorides, if I put a coefficient of 3 there, and a 2 as a coefficient in front of the aluminum chloride, that gives me 6 chlorines on both sides. And now I can go ahead and balance the metals. So I've got 3 calciums now on the product side, so I can put a coefficient of 3 in front of the calcium. And I've got 2 aluminums on the reactant side, so I'll put a coefficient of 2 in front of the aluminum on the product side. There we go. That's good. Let's do another example. I've got silver chloride, and it's undergoing electrolysis. That's what I'm trying to indicate with the electron over the arrow. Now, I've only got one reactant. That means this must be a decomposition reaction. Decomposition reactions mean I'm going to make it into something simpler. Since it's a binary compound, it needs to break down into its elements. And for my chemistry students, that's what I expect them to do. There are actually a lot of different types, subtypes of decomposition reactions. I focus on decomposition of binary compounds with my first year classes. So I need to make silver metal, and I need to make elemental chlorine. But I have to remember, and this is an easy thing to overlook, that chlorine is a diatomic element. So I have to write it as Cl2. All right, so it's silver plus Cl2. I'm going to make the elements here from this binary compound. So now I can think about balancing. I've got 2 chlorines on the right, so that means I need a coefficient of 2 in front of the AgCl. And so to finish balancing the equation, I need a coefficient of 2 in front of the Ag on the product side. Good. Okay, in this reaction, I have aluminum reacting with bromine. I've got 2 elements. Well, I guess they're going to form a compound. The only logical conclusion here is that this is a synthesis reaction. I do expect my students to be able to take 2 elements and write the binary compound that would form between them. So this is synthesis, so I'm going to make some combination with aluminum and bromine. I've got a metal with a nonmetal. It'll be an ionic compound, so let's think about charges. Aluminum, when it forms an ion, has a charge of +3. Bromine, when it forms the bromide ion, has a charge of -1. So that means I'm going to need 3 bromide ions for each aluminum. So I would write AlBr3. Yes, I know that bromine had a subscript of 2 on the reactant side. In its elemental form, it's a diatomic molecule. But here in the compound, I need 3 bromide ions for each aluminum. So now I can think about balancing. I've got 2 bromines on the left and 3 on the right. So if I put a coefficient of 2 in front of aluminum bromide on the product side, that gives me 6 bromines, which means a coefficient of 3 for the bromine on the reactant side for the bromine molecule would give me 6 bromines. So now I just need to finish balancing the aluminums, and I've got 2 aluminums on the right, so a coefficient of 2 for the aluminum on the left will finish this off nicely. All right, let's do another example. I've got C4H8 and oxygen. Oh, oxygen is a reactant. This is probably a combustion reaction. It is a combustion reaction, combustion of a hydrocarbon, right? C4H8 is a hydrocarbon. It's just got carbon and hydrogen in it. When I do this combustion, I'm going to make 2 products. Combustion of hydrocarbon always leads to CO2 and H2O. So now we can think about balancing. So I've got 4 carbons in the hydrocarbon. So if I put a coefficient of 4 in front of the CO2, that'll balance the carbons. And then I've got 8 hydrogens in the hydrocarbons. So if I put a coefficient of 4 in front of the H2O, that'll balance my hydrogens. And now if I count up all my oxygens on the product side, 4 times 2 is 8, plus 4 is 12 oxygens on the product side. So a coefficient of 6 in front of the O2 on the reactant side will give me a balanced equation. Nice. I hope you found this helpful. You need to do a lot of practice problems of this type to get really good at predicting products, writing their formulas without mistakes, and then balancing the equation. You're putting a lot of skills together in this kind of problem set. Subscribe to my channel, leave a comment on the video if you liked it, and like the video as well.